Well, hello everyone, and welcome to the first in a series of webinars brought to you by Tilia Labs. I'm George Follickman, Director of Sales and Business Development for Tilia Labs, and I'm joined today by my colleague Tyler Thompson, Global Director of Solutions and Technologies. Today we'll be taking a dive into artificial intelligence and its practical applications for print and packaging converters. This is intended to be an interactive event, so please feel free to use the Q&A functions of Zoom to ask questions. We will answer them in real time or at the end of this presentation. If you enjoyed today's event, please visit sales.tilialabs.com/events to see our upcoming webinar lineup. And without further ado, I will pass it off to Tyler Thompson.
Great, thanks, George. And George, if you can just confirm that you saw the transition of the slide.
Yes, sir. We are looking good.
Perfect. Great. Well, thank you, everyone. Thanks for joining. Thanks for taking the time out of your day. I see, well, last we checked, it looks like just over 15 countries are represented today on this webinar. It's pretty crazy. So I hope everyone is staying safe. Yeah, again, just really appreciate your time. So as George said, my name is Tyler Thompson, and I'll be hosting today's webinar. My role at Tilia Labs is Solutions Director. I've been in the packaging and graphics industry ever since graduating from Clemson University in the graphics and packaging program. So if there's any Clemson alum on the line, go Tigers. And I'm based in South Carolina and hold a master's degree in computer information systems from Denver University. If you have questions or want to reach out, contact me, feel free to drop me an email, tyler@tilialabs.com. So the agenda for today, we're going to start with an introduction of Tilia Labs, talk a little bit about who we are and what we do. Then we're going to dive into what really is the problem that we're trying to solve with our technology. And once we define the problem that we're trying to solve, we're going to discuss how Imposition AI and our technology is helping other printers and converters. And during that, I'll also include a handful of demonstrations of the technology in various different applications, various different industries. And then last, like George had mentioned, we'll have a live QA session where you can just chat over the questions, and we will try our best to answer them as quickly as possible. So a little bit about Tilia Labs. So we're a software company, and we're only a software company. We're not tied to any hardware. We are very proud in the fact that we are solely a software development company in the printing and packaging industry. And in 2019, we recently won an Intertech award. So this past Intertech award, we received an award for our true AI technology. In fact, that's exactly what we're here to talk about today. So like I said, software company, we were founded in 2012, so we're relatively newer to the industry. We're based in Ottawa, Canada. We have a development team who sits in Toronto now, a team here based in the US, and then also a team in Tokyo. And we're a small, highly skilled just group of developers. And year to date, since 2012, we've got just over 500 licenses sold. And we have global distribution of those licenses sold into over 32 countries. So, well, actually half of those being represented on this webinar today. And then we've got a bit of a product mix since 2012. We've came to market in April of 2012 with our flagship product, Phoenix, which is what we'll be focusing on today. But if you look, as George mentioned, we've got a series of upcoming webinars that you can check out on sales.tilialabs.com/events, where we'll be talking about our other technologies, such as Griffin for sign and wide format. We have a product called Tilia Aries for label, step, and repeat. And then also our Tilia Cloud platform is our cloud-based licensing tool. So our customer market in mix, we started in packaging, and that is still our largest customer breakdown of segments. But we're finding ourselves quickly growing in both the commercial and sign and display, and labels is also with frame optimization quickly catching up as well. So we've got and are proud of our mix and breadth of customers that we can that can leverage our technology and tools for planning and positioning. So AI, well, we hear that term being thrown out a lot, but it's actually used really everywhere. Everywhere you look, frightening enough if when you look in your phone. Unfortunately, there is AI that's looking at your face and being used by tools like Facebook. And of course, self-driving cars is probably the most apparent to us, where AI is driving and making decisions in real time to steer a car. And same within the medical industry. There's AI that's looking at several billions of skin cells to determine if it's a cancerous or non-cancerous cell. And AI is not just used in the automotive and in the medical industry, right? But it's being used more and more every day to look at extremely large data sets and evaluate the best route or most cost-effective route to solve a problem. And AI is only going to continue to keep being more and more relevant. So, what in our industry, how is this being applied, or really what is the problem that we're solving with our Imposition AI technology? So let's talk a little bit about one big and potentially or very large problem that we see every day, and that's this process of human planning and human estimation. So this is a standard process that's happening in a printer converter, where you're looking at several orders that need to be produced and manufactured and trying to figure out how do we take these orders with their various quantities and figure out the most cost-effective way to produce these in our given production environment. And this is a process that takes typically 2 to 3 days of production planning time. Then it needs to go into the CAD department to generate the dies or to generate the finishing components. And then all of that information gets handed over to the prepress team for another 1 to 2 hours for impositioning. And this process is challenging because it's a really hard problem to solve. In this particular scenario, where you're running a single item on a B1 press sheet, it's actually a pretty easy problem to solve. And if we just look at the quantities and we know we're just going to run this particular item on one press form, it's pretty simple math. But it gets more complex, and it starts getting exacerbated when we include or introduce additional SKUs that we need to plan. So in this scenario, the problem that the printer converter is being challenged with is, how do I take, well, in this case, just these 2 orders and figure out the most cost-effective way to plan and produce these jobs. So we've got one SKU that's got a quantity ordered of 50,000 and one that's got 25,000. And we know from the previous slide that we can only fit 8 up on a sheet. So then the question is, how do we, with their quantities, divide it in the most cost-effective manner? Do we, A, run a scenario where we're just running one press run and running a 20% overage on the orange SKU, or this is going to return us 10,000 sheets, or do we try and save some material and actually not overrun in this case and run 2 press runs? And what's more cost effective, right? Do we introduce another press run, which incurs costs of press cleanup and waste and make ready in plates? Or do we save sheets and run it like you see on screen? And then this problem gets even more complex, and there's even more permutations when we start introducing a shape. Because with a shape, the problem, that is the way that this problem is typically being solved in the industry is by looking at the outer dimensions or the lay flat of that shape. Right, so you're looking at the length and the width and doing the math and figuring out, hey, I can get 6 up on this B1 sheet. Um, however, when you nest these things and put them together, well, guess what? We just increased our or decreased the number of sheets by 33% because we got another row, right? And this is the reason why we see in many cases this process of production planning and impositioning being done in a manual fashion. So to make it a little bit more challenging, how do we take now these 9 SKUs at various quantities, different inks, right? And run them in the most cost-effective way on our sheets, right? How many press runs is this going to take? How many sheets is this going to take? This is where the problem starts quickly becoming an extremely large data set to evaluate. And that's because we have, a number of different orders. We've got varying quantities and allotted overruns within those quantities. You may have one or many presses, one or many locations, different stock sizes, different potential dies or die configurations, finishing equipment, plates. Do we run a digital or offset or flexo, right? You can quickly find yourself with well over 45 billion possible combinations for just this 13 SKUs. So for a human to sit and think about and evaluate these different permutations, it becomes extremely challenging. And this is important in our industry because as we see SKUs continue to proliferate, right? We don't see a convergence of products in CPG or in beauty or in healthcare. We see the opposite, right? We see SKUs proliferating. We need not just 5 flavors, but we need 100 flavors. And the printer and converter is getting challenged with this, shorter run lengths, an increased number of SKUs that they have to manage. And the turnaround time needs to be the same or faster in many cases. And then the printer converter has to manufacture and decrease their costs while all of these other challenges are being imposed on them. So this problem of human planning is what we're out solving, right? We want to be able to leverage AI or provide the industry with artificial intelligence at their fingertips to evaluate an extremely large data set of possible scenarios and hone in on the most cost-effective way to run the job. And if we do that, if we plan smarter, we're going to save money. And in this one particular example, this use case from one of our customers, doing about 50 million in revenue USD, saw potential savings of upwards of $46,000 a month. And that is by simply increasing the number of items per press form from 2.1 in 2018 to 2.5. That slight increase in number of items per sheet allowed for a significant reduction in press downtime and changeovers. So I want to introduce Imposition AI. And Imposition AI is the industry's first artificially intelligent planning and imposition algorithm. So with Imposition AI, Phoenix is able and capable of evaluating an extremely large data set in very little time. Once Phoenix is knowledgeable of the press and costing environment of production, it's capable of evaluating and honing in on solving the problem of figuring out the most cost-effective way to combo and produce jobs. And because of this, AI-assisted planning has taken what the industry was typically seeing of about 3 days in production planning, prepress, and CAD down to 15 minutes or even smaller in many cases. And the realization of waste is upwards of 15%. And this has enabled our customer base to understand cost and further distribute their manufacturing across one or many of their locations. So how does this help? How does Imposition AI help solve this problem? Well, for one, we want to ditch human planning. And well, humans are by nature a bit lazy, and humans take the path of least resistance and, well, can simply just not compute as many different possible permutations as a computer can. So in order to do that, in order to leverage AI, we need to make Phoenix or Imposition AI aware of and teach it about the production environment. So Phoenix needs to become aware of the costing of the presses, the different presses and configurations of presses in the production environment, the finishing equipment and the stocks and stock costs and make ready costs. And you simply do this by modeling your production environment inside of Phoenix. So I've got a CD102, my offset press, and I've specified things like my cost per hour, my make ready time, minimum run lengths, and some constraints on the min and max sheet size. And also made Phoenix aware of the setup, make ready, and plate costing and running waste cost of my presses and my finishing equipment. And I do the same thing for my stocks. Once Phoenix understands both the production, finishing capabilities, as well as the stocks, different stock sizes and costing of those things, it can begin to hone in on the most cost-effective way by evaluating several different ways of running your batch of orders across your different presses and across your different stocks. So let's take a look at how this works. We're going to start with a sheet-fed offset planning scenario. And I'm now inside of Phoenix. And what I'm going to do is I'm going to start by importing a data sheet. And the data sheet is that you see I'm importing is a CSV file that came directly out of my business system. And the CSV file you can see contains a list of orders. And the list of orders contains my order quantity, my bleeds, my stocks, my min and max overs, and all the other important information about the order. And you simply drag this file into Phoenix. Phoenix will then ask you to map the information, which I've already done, and you click OK. This will import all of your products into Phoenix and pull in all the necessary information from your order system, right? So you can see Phoenix brought in those 13 orders, and each of those orders now has in the left-hand side there has a specified order quantity, right? So we've got 10,000, 5,000, 3,000, 7,000, 1,800. And I've already modeled all my costing. So you can see in the bottom left-hand palette there, my presses. I've got several different presses in my simulated production environment. I've got an offset press, a couple digital presses. I've also specified costing in my different stocks and modeled those in Phoenix. Now what I'm going to do is ask Phoenix to run what we typically see in the industry, which is this kind of just take each one of my items and run them a single item per press run, right? So don't do any combination, but rather just run each of these orders on its own press sheet. And you can see within a couple milliseconds, Phoenix solves that problem. So when I brought in those 13 orders and I asked Phoenix to evaluate a single item per press form, I specified my B1 press sheet or 40 by 28 inch press sheet. Phoenix then quickly built and costed and figured out how many out can fit on each one of those sheets. So it generated a press form for each one of my orders. So 13 press forms. And Phoenix also says that it's going to take a total of 8,641 sheets to produce this batch of orders and 13 hours on press. That's because we ran these all on our offset press on one sheet size with 13 press runs. So that's 13 make readies, 13 press cleanups, right? And the result of Phoenix is a fully imposed print ready file. So not only did Phoenix cost the job and plan the job, but it also created the fully imposed press form for each one of our orders from that CSV file. So again, that resulted in about $8,000 of cost based on my modeled production environment. Now what I'm going to do is I want Phoenix to look at several different permutations. So I'm going to use the default profile of Imposition AI and harness the power of Imposition AI. And I'm going to introduce another press. So I'm going to evaluate this particular scenario on a CD102, our offset press, as well as my Indigo, my 19 by 13, 7900 sheet fed Indigo press. And I want to evaluate this on 39 different possible sheet sizes. So now what Phoenix is doing, there is an infinite number of ways to take these 13 orders with their min and max overs against my 2 different presses, against my 39 different sheet sizes. The number of permutations is really infinite. And what Phoenix is doing, you can see at the bottom right there, in about 20 seconds, we've returned about 1,200 plus results. So I'll stop it here. And the results are sorted by cost, assuming you want to produce the most cost-effective press runs. That's what Phoenix has solved for by looking at that very large data set. And what Phoenix determined is the most cost-effective way to run this job is to actually run just 1 press form on a CD102 and 4 other press runs on our 19 by 13, a 4 sheet on our 7900. And now you can see the total cost of running this job went from $8,000 down to $1,000, right? And we decreased our amount of time on press from 13 hours down to 5 hours. So Phoenix also then created dynamically the imposed file that's ready to be sent directly to your plates or directly to your digital press. So the result from Phoenix then is this, of course, the print and cut files, but also a production report. And the production report shows a nice PDF report for each one of your press forms, gives the details about each press form, what press it's running on, and the sheet size that Phoenix determined. And then from that CSV file, Phoenix also spits out each one of the items that were ordered. And just to show you an example of what Phoenix is capable of doing here, in this particular scenario, I let Phoenix auto-compute the best, most cost-effective way to run the job. And what Phoenix determined is that for this particular item here that the customer ordered, they ordered 7,000. And Phoenix said, look, it's best if we run this by almost 50% overage. And we're now going to go from 7,000 up to 10,300 total. And what normally happens, what we normally see is a planner, when they're looking at items to potentially combo, they will sacrifice a certain percentage of overrun. Let's say it's 5% or 10% over. What would normally happen is if you can't find a combination that achieves that 5 or 10% max overage, a planner will take this item and move it to another press form. And because we've modeled our cost inside of Phoenix, what Phoenix is saying or suggesting here is that, look, it's actually more cost effective to run this on an existing press run with the other items versus moving this to a new press form, because Phoenix knows that you're going to introduce a press cleanup of about an hour, and your press cost center is $380 an hour, plus you're going to incur costs of 4 more sets of plates, your make ready, and additional potential material. And Phoenix is suggesting and saying, look, it's actually most cost effective to run this on an existing press run versus moving it to a separate press run. So that concept then can be applied. This optimization in AI-assisted planning algorithm can then be applied not only to the commercial sheet fed side, but now we're going to look at several other examples, industry examples of how this is being applied outside of just commercial sheet fed. So in this next example, we'll see a sheet fed die cut planning scenario where Phoenix is going to use its pattern matching algorithm to go find an existing steel rule inventory die from your die database and use it to figure out how do we populate our orders or our items across that die, distribute them across that die in the most cost-effective manner. So again, I'm starting right inside of Phoenix, and Phoenix is cross-platform, so this technology can be leveraged on Windows or can be used on Mac OS and also on a Linux platform. But when I bring in, now what I'm going to do is I'm going to bring in a list of orders here again from a CSV file, and instead of just 13 items, which is what we planned on our last press run, I'm going to bring in a much larger set of items here, and I'm going to import 1,030 different packets here that are going to be planned on a steel ruled die. So you can see Phoenix goes and finds all of those files and pulls them into Phoenix and sets all the information about the quantities, right? We've got quantities ranging from 500 upwards of 30,000 in this particular scenario. So 1,030 items. Again, relying on a human to compute this large data set is extremely slow and likely not very cost effective. Versus leveraging our AI technology, where we start at about 25 press runs and $13,000. You'll see Phoenix now is going to start looking at all of the different possible combinations of taking these 1,030 items on a 40-inch press sheet or B1 press sheet, and comboing them in different ways to reduce the number of changeovers and reduce costs. So you can see now after about 2 minutes of planning, we started at around $15,000 in cost, and we've got that down to 12,000. And Phoenix's ability to hone in and solve this problem in a very efficient and cost-effective manner allows for our customers who are dealing with smaller run lengths, trying to optimize their press runs and plan their press runs in a much more cost-effective way. Furthermore, Phoenix, as you can see here, is not only planning and estimating the job, but also figuring out and creating the fully imposed print-ready PDF file. And if we don't have an existing die in our die database, I'm going to now take this example where a customer has sent me a list of items. I don't have artwork in this particular scenario, but I do have dies. So I've got the one-up die lines. And now I'm going to allow Phoenix to leverage, to couple its optimization AI algorithms with its true shape nesting algorithms, which just further increases the number of different permutations, right? Because what Phoenix is now doing is it's not using a standing die, but rather it's looking at these 36 items, these folding carton jobs here with their quantities, and aggressively comboing these items to create a die on the fly dynamically and try and reduce the number of changeovers. And in this case, with these 36 items, which would normally run an item per press run, we've got down to four layouts here at $5,000. Now we can add some logic to our AI algorithm. And if I want to keep these in strips for finishing purposes, so coming off my box die cutter, maybe I don't want the entire kind of free form die, but rather put my dies or allow my dies to be, my items to be in rows nested. So you can see Phoenix is quickly going to now keep all of our items in rows to make it easier in finishing. And then I'll just scroll to a little bit further. And now if I run this, so we've started at about $5,000. Now I'm going to run a single product per sheet. So I'm not going to do any combination, but rather have Phoenix plan this job on a 40-inch or B1 press sheet. And there you see Phoenix generated all of our imposed files and dies. And now the cost is, well, $28,000 versus $5,000 if we allow Phoenix to nest and impose our files. And last, I'll show a wide format demo to show our nesting optimization for wide format. So same scenario here. I'm going to import a CSV file. And this is going to be a POP job. So a point of purchase display for a digital wide format scenario, a corrugated scenario here. And I'm going to import from a CSV. And Phoenix is going to bring in our print items here. And you can see Phoenix has auto-detected the die line and set the shape based on the outer cuts. And I've got, this is a multi-part display, but I've got several components, 64 components, different quantities, and I want to run this on my digital wide format press. So now Phoenix is going to couple its optimization and costing AI algorithms with the true shape nesting capabilities to not only plan the job, but also pack and further optimize our cost, material costs, to create and figure out the most cost-effective way to impose and plan these jobs. So now you see the optimization algorithms won't run as fast, obviously, as when it squares, and we're running several thousands of different results in seconds, but rather after about 30 seconds, we've got 15 different ways of optimizing. I'll stop it there. And quickly, Phoenix has now optimized our orders on our most cost-effective board size, and also fully imposed the file for both digital print and digital finishing. So the breadth of Phoenix and the capabilities of Phoenix go far outside of just your traditional planning squares, right? By coupling our technology from packaging with our optimization algorithms and costing algorithms for commercial, Phoenix is truly a one-stop shop for leveraging or having this AI algorithm at your fingertips for planning and nesting across several different print technologies. And this concept and speed has allowed our customers to truly leverage press side planning or just-in-time planning, where in many cases, digital press operators who are leveraging Phoenix don't know what the next press form is, and instead allowing Phoenix to go on the fly, generate these fully imposed print ready files to be delivered directly to the press as soon as the press operator is ready to start the next job. So we're not stopping there. Like I said, we're an active development group in the industry, and certainly see and hungry for more. And we have, unfortunately, with the postponing of Drupal, where we wanted to introduce a ton of our new features, we'll be postponing, but giving you a sneak peek at a couple of things that are in our pipeline coming in 2020. So Phoenix is getting smarter every single day. And one way it's getting smarter, especially with digital, is evaluating ink coverage costing, both with ink coverage calculation and modeling your costing for digital inks and conventional inks, but also a click-based click-based ink calculation. And this is going to help our customer base truly figure out and have more intelligence and costing at their fingertips about evaluating digital versus conventional printing, making Phoenix even smarter and more valuable. Furthermore, we're introducing devices and leveraging IoT connectivity via Phoenix. And in 2020, we'll be releasing an IoT-enabled, really the first IoT-enabled planning and imposition solution in the market. And our first IoT connected device is going to be Zund, the Zund digital cutting device. And this is going to help especially our digital customers evaluate not only do we run our jobs and what is it going to cost to run our jobs digitally printed versus conventionally printed, but now the big question mark is, what are those jobs going to cost in finishing if I finish them digitally? And by leveraging IoT, as we start generating the permutations and different results, we send those to the IoT-enabled Zund device, and you can see in the right-hand side there, we're getting true cut time estimates back right at our fingertips to truly understand, do we generate a die? Do we run this on a die cutter? Do we run this on our digital table? And what is that going to cost in production costs and time? So with that overview, I'm going to open it up for questions at this point. I know George has been monitoring the chat channel. So George, I will pass it over to you for questions.
Yeah, Tyler, first off, fantastic presentation. Thank you for that. A lot of activity in the Q&A window here. So I'm going to ask I'm going to combine a couple questions here into one. We've got an attendee using FileMaker for order aggregation. There's a couple other MIS systems and some workflow systems that our attendees are using. Can you elaborate a little bit on how Phoenix can connect with these outside systems?
Yeah, great question, George, or whoever the attendee was. So yeah, I guess there's two parts to that question. One part is the connectivity with other workflows. So Phoenix, the result of Phoenix, both the imposition files can be and cut files can be exported as PDFs, so they can be sent directly to another workflow or a RIP via PDF. But we also support JDF connectivity. So, you know, with many workflows out in the industry, we also have the ability to send our planned results as a JDF file, which can then be consumed by a workflow system to then handle the PDF generation with any of their custom metadata or value that the workflows bring into the table. And then connecting with other business systems. So FileMaker, for example, in fact, that the CSV files that you saw were CSV files directly out of FileMaker. And Phoenix comes with the ability to consume a CSV file, which pretty much all MIS ERP systems can export a CSV file of your order information, which we make it very easy inside of Phoenix to consume and map that data into Phoenix so that you can just drag your CSV order files into Phoenix and populate all of your order information with substrate, quantities, etc. Also, just one more thing, sorry, George, but we also have a full REST API. So can you see the screen?
Yeah, yep, we can.
So we've got a fully documented RESTful API as well. So this allows highly customized integrations in a very simple kind of visual way through our REST API. So everything you saw on the demo can be facilitated through REST.
Awesome. Awesome. So we had a handful of questions around dies and templates. Well, first off, I guess, can we generate CAD layouts in Phoenix, and then can those be exported to an external CAD program? Let me ask a couple questions here. So can we export those to an external CAD program? Can we import existing templates? And if so, in what formats can we import and export these CAD files?
Yeah. So, yep, good question. Phoenix is capable of, so the results that we generated, similar to the results that we generated in our example, can be exported as CAD file formats to be then imported in a workflow, or to be imported in a CAD program for die making. So in Phoenix, when you're exporting your die layouts, you can export that as industry standard CF2 files, DXF, PDFs, or ZCC for digital cutting for the Zund. And then importing, so when we're importing templates, like you see in the bottom right hand side here, Phoenix is capable of also importing DXF, DDES, all the industry standard file formats for CAD file formats. So DXF, also PDFs, CFF2s, of course. So yeah, we support all of the industry standard CAD and packaging file formats for both one-up die lines and multi-out die lines.
Awesome. Awesome. And then for commercial work, when Phoenix is generating its forms, do we also have any understanding of finishing? For example, sheet turns for cutting. Is that also taken into consideration?
Yeah, it is. So once Phoenix starts evaluating the different permutations, if Phoenix does find start honing in on a cost that can't be further reduced, then the algorithm starts to look at further optimization. And further optimization is, like you had just mentioned, for guillotine cutting, for example, it's reducing the number of sheet turns and finishing by intelligently moving items to the edge of the sheet to line up your first cut in an automated fashion to further reduce cost. Furthermore, yeah, Phoenix also has the ability to cost and model costing for dies. So in Phoenix, you can specify your different post-press costs and model your cost for the linear inches of rule for all of your different line types, right? To estimate and understand what is the cost going to be if I build a new die versus and create a new die with my die vendor or internally versus running this on an existing die.
Awesome. Awesome. Is there a limit to the number of jobs Phoenix can process? For instance, one of our attendees receives like a 1,000-page PDF for their HP device. Is there a limit to the number of products in a job or the number of products that we can process?
There's not a limit per se. When it comes to true shape nesting, of course, where we have several different shapes, upwards of 2,000 items is the recommended kind of max number of simultaneous items to look at. But when it comes to like commercial and direct mailing and transactional type printing, where it's square cut postcards or mailings, we've got a large customer doing registration ballots for the upcoming election, right? And they're doing upwards of 200,000, 500,000 items in Phoenix in minutes. But when it comes to true shape, and you have a ton of different tiny shapes, around 2,000 is where we typically recommend the cap for true shape.
Awesome. And I'm going to ask one more question here. I like this one. Do you have any generic libraries of presses that can be loaded into a trial version for evaluation? It sounds like this attendee has considered or used a trial in the past and is curious about maybe setting up a trial pretty quickly.
Yeah. So we're every day continuing to add to our library of cloud presses, just to make it easier to set up the constraints of the equipment. Of course, our cloud library isn't going to have any of the costing. That's of course modeled by the customer, right? The hourly rate of running the press and average make readies. But we do have a library, cloud library of devices that we'll be releasing in our version 7 to help our customers get started faster.
Awesome.
Yeah, good question. It does not exist today, so that's a sneak peek there.
That's coming in 7. All right, great.
Yep.
Awesome. Well, Tyler, that's all the time we have for today. There were a few questions that didn't get answered, but we will reach out afterwards with responses for all the questions. I really appreciate everyone's engagement today. Yeah, there was quite a lot of really good good questions that came in. Thank you again for everyone who joined. If you found this content interesting, again, I know Tyler's plugged it a couple times, I have, but please do visit our sales.tilialabs.com/events page. We've got some upcoming webinars that'll take an even deeper dive into each of the print segments that we've discussed today. So I believe our next one is wide format. We've got one coming up for labels. We've got one specifically for folding carton. for digital corrugated, and then last but not least, our commercial print segment, so flat and folded commercial print work. So do check those out and sign up for those. Thank you, everyone, and have a great rest of the day.